And welcome back to the Private Cloud Jumpstart. We hope you had an excellent day one, but day two is going to be even better. We're going to go a little more technical. We're going to go really into monitoring and operating the entire environment. We broken it down again across the several days. We're back with three of our presenters, Kenan Owens, Adam Hall, and Sean Christensen. So we expect to have a ton of great content in this Jumpstart, creating and managing a private cloud with System Center 2012. I'm Simon Perryman, Technical Evangelist with Microsoft. Prior to this role as the Private Cloud Technical Evangelist, I spent 4 years on the engineering team working on high availability and cluster features in a variety of roles. Kenan, why don't you introduce yourself again?
Thanks, Simon. My name is Kenan Owens, and I am a Senior Product Marketing Manager here at Microsoft, focusing on the infrastructure components of the private cloud. I'm really focusing on how System Center can help deliver the private cloud. And today we're going to talk a lot about the monitoring and operating. After it's all configured and deployed, what do we do afterwards?
Thanks. So let's take a look at where we are across the entire agenda of the Jumpstart. Once again, today is really focused on monitoring and operating. So we've assumed that you have the infrastructure up and running,
right.
It's stable, it's being deployed, it's being configured. Now we're really going to focus on how do we optimize it and how do we really take advantage of lots of those themes of the private cloud. You know, continual self-service, better automation, but more important, better response time to any type of problem. So we're really going to tie in a lot of interaction with Operations Manager throughout the day across all of the modules. So Ken is going to be joining us for this module as well as the next module, talking about both the private cloud infrastructure and the infrastructure components. Right. A little later, Sean will be back to talk about service delivery and automation. And at the end of the day, Adam will join us once again to cover application management. So why don't you give us a little more detailed breakdown of what we're covering in this module? And once again, can you remind us what's the difference with private cloud infrastructure and the infrastructure components?
Exactly. So in this module today, we're going to talk about monitoring and operate the infrastructure components. You spent all the time yesterday and however long it took you to get this private cloud created and it's up and running. Now that it's up and running, you want to ensure that you're proactive and you can handle any changes in the use of the private cloud, corrective, where if there's a problem with the infrastructure, you can fix it. You can standardize how you update the underlying infrastructure components and that it's available for use and problems get fixed very quickly. Now, there's infrastructure components, and then the next session will be private cloud infrastructure. Again, the infrastructure components are those physical devices, your computers, your storage, your networking devices, and how they're actually running and performing. We're looking at things like how are the OS performing, if there's a problem with the underlying physical hardware, can I monitor my network and devices, those types of things. When we talk about the private cloud infrastructure, I've taken all these infrastructure components together and I've now created a private cloud on top of them, and that's where the private cloud infrastructure is building all that, taking all those resources, putting them together and aggregating them, and then showing them up to the private cloud. So before we get started here, there were a couple questions from the configure and deploy session that I wanted to just address, and one of them that we talked about was, what's the SQL? How do I handle SQL Server in these environments? With things like VMM 2008, there was a SQL Express that I could use, but with VMM 2012 and with the System Center 2012 components, you would use a full-blown install of SQL, and you need to install on that. You can't install on like SQL Express. But what we do is when you get the System Center 2012 licenses, you're allowed to run a SQL Server and put your databases on top of there. So you don't have to, so you'll be able to get a version of SQL that you can install and run and attach your System Center licenses to.
So you're saying it's not an additional acquisition, it just comes as part of the System Center 2012?
Right. So you can run this a SQL Server and you can install the databases for your System Center components against it, but it can only be used for the System Center licenses. You can't take that SQL license and run other SQL databases on it.
Now, what happens if our customer already has SQL in the environment? Can they use that existing SQL instance?
So if you already have SQL in the environment, it's already licensed, you can always install your databases from VMM or Systems or Operations Manager or whatever on those SQL servers.
Okay, great. So key message, you no longer are going to be able to use SQL Express. You will need a full version of SQL, but it does come with the System Center product. And if you already have SQL, you could continue to use that.
Exactly.
Thanks.
Great. So you've seen this slide, I'm sure, a few times throughout the day, and what we're going to be focusing on today in these sessions is now the monitor and operate part of managing your underlying infrastructure. And here, we're really focusing on making sure that the services that you have are up and running. It allows you to provide a productive infrastructure and allows you to move to the private cloud on your terms. So the things that we showed you in the previous sessions was really getting things up and running. Now we're going to show you how to keep it up and running. Just a little quick recap, or if you are just joining for this day. If you look at the private cloud, what we're trying to do here is take all of your different physical types of infrastructure, whether it's your different types of compute resources, like different types of servers, your different storage devices, or your network devices, and really pull them together into something where we can create this logical and standardized environment. By putting them into this logical and standardized environment, we can now create private clouds on top of them. With this cloud abstraction, we've taken these physical resources and put them into something that we can now give out to any of our line of business users or our application owners. So that means we can delegate this capacity to these individual users, and they will deploy their applications or their services on top of them. We as a IT guy can give them a standardized set of services so that they're only deploying the applications or the services that we give them permission to deploy, but they can do it on their terms. They don't have to wait for us if they don't want to. When this is already deployed and everything's running, you want to make sure that you can continue to ensure that the OSs or the applications, the services, everything's up and running in a way where you're meeting the SLAs for your infrastructure. So we're going to be proactive in monitoring this infrastructure. We want to take corrective actions if something happens. We want to quickly be notified that there's something that went wrong. And if something does go wrong, we want to be able to drill down and find out exactly what went wrong. We want to be able to use our knowledge or the knowledge of the companies that make the application to find out where that problem is and fix it quickly. Also, we have this private cloud infrastructure available. Maybe I have a bunch of Hyper-V clusters in there. I want to ensure that I can keep them updated and update them without bringing down any of the applications or VMs or services running on top of them. And then whether this application is running here in my data center or it's running across multiple data centers, I want to make sure the application is available by ensuring that the infrastructure itself is available.
Yeah, remember, availability is really important for the business as well. These businesses, it's a 24-hour-a-day business. Anytime that you have a service go down, don't forget, your business is losing money. That service is no longer available to customers. They're not making revenue. Your business is upset. So having this high availability, having this constant monitoring, but more importantly, the automated resolution to minimize the downtime or to be able to recover quickly, that's going to be an essential component of the private cloud.
Exactly, and it's important in that I would rather be paged in the middle of the night with something that says, this went down, but it's already been fixed, than it went down, now get up, drive into the office, and go fix it
yourself.
Exactly. So let's talk a little bit about how we can understand how our infrastructure is performing through the performance monitoring capabilities that we have in the Operations Manager component of System Center 2012. So one of the things that, and probably a lot of you are familiar with Operations Manager, probably a lot of you are using it or have used it before inside of your organization. But we give you a really good ability of monitoring both your compute and your OS, that physical server resources. Those are things that you probably remember from running Operations Manager over the last however many years you've been doing it. It helps to know how these applications are performing so you can know whether or not you're achieving your infrastructure SLAs. In other words, I want to know not only is the application performing well, but the underlying physical hardware it's running on. And as I start virtualizing things, more and more of these servers get put on top of one physical server. So I need to know if that server is performing appropriately. The other thing is I want to be able to trend this usage over time. I want to know, is my private cloud running great now, but I'm starting to use up all those different resources and I need to maybe expand those resources, or if I'm hitting different trends where every 3 months I get this really busy cycle or something like that. And whether or not I have these servers that are out there, if I have servers from different companies, I want to get the full insight into how those servers are performing. And I can do that by using either Microsoft provided or partner provided management packs. So these management packs are something that allows me as an organization to get the knowledge and the information from an existing, from either Microsoft or an existing partner. So we provide from Microsoft a lot of different management packs, especially for Windows OS, all the Windows OS components like Active Directory, those types of things, as well as the Microsoft provided applications like SQL Server and Exchange and those types of things, IIS. By using these management packs and importing them into Operations Manager, you can set thresholds and know how these applications are performing, know when it's maybe running above a certain value and that it's going to have problems. And so we can look deeply into that application. We know how that application should perform and give you those common thresholds. But the fact is that you as an organization may have different ideas on how these things run, because in your environment it's going to be different than everybody else's. So you may want to override some of those thresholds, and you have that capability. The other thing is that for applications from third-party partners or from third-party hardware, they may provide their own management pack because they have the expertise on how their applications or their hardware runs, and they can provide that information for you. So you have this type of information available to you.
What about authoring your own management pack? Is that possible? You have a custom line of business application?
That's absolutely possible, and that's one of the things that we provide with Operations Manager is the ability to author your own management packs and put things together. Maybe my custom application has a web server, a SQL server, and an application server. I can put a management pack that looks at all of these things and maybe determines thresholds as far as when a user connects in, how much that latency is, and can know the threshold for that. It can look at specific performance counters and know, hey, if this performance counter goes above a certain value, I'm going to throw an alert or something like that. So you can create your own management packs as well for your own application.
So you can monitor pretty much anything in the environment, from hardware, software, custom applications, servers, virtual machines.
Exactly. You can do all that, and you can create connections between all of them. So I know that this service is running on these virtual machines, which then know that these virtual machines are running on this physical piece of hardware. So I have that connection between everything and know if something's down, where to go to look at it. That also allows me as an organization, as I'm running these applications, to be able to put my tribal knowledge into these management packs. So an organization puts in a management pack, installs a management pack, and inside that management pack we have product knowledge from either Microsoft or the organization or the third-party company, and that gets stored as product knowledge. But what if every time this problem happens, not only do I have to do the things that are suggested by the company that created the management pack, but what if I also had to do something like I had to go and communicate with my DNS server and reset some DNS name, because in my network environment, that's always what happens when this problem occurs. I can put that information in the company knowledge so that even if I'm not in the office at that time and the problem occurs, someone pulling up the alert can look at that company knowledge and say, oh, this is what things I need to do to fix this thing in my organization. So they get that information, and I can just customize my management pack to add that company tribal knowledge that I have. The other thing is maybe I've overridden something where the threshold is 50%, but I drop it down to 20% because I know that it runs fine up to 20%. Then I can put that in there, that override in there, and then I can explain why I did that override so that someone doesn't just go back and convert it back to something that maybe doesn't work in my environment. So I have all this flexibility in not only finding out what the problem is, but telling them what's the best way to fix it. The one thing we've added with Operations Manager in the System Center 2012 is that we added this new out-of-the-box network monitoring. Before, you'd have to download management packs for each of your different network vendors, and if you had a problem, to really do your network monitoring with the Operations Manager, you have to install, say, a Cisco management pack, Juniper, or something like that. With out-of-the-box network monitoring, we actually have discovery for multiple vendors and multiple different types of network switches, whether they're using different versions of SNMP or connectivity for networks that are running on IPv4 networks or IPv6 networks. We can discover all these different network devices that are out there. You can have either really full network monitoring or at least know that these devices are available. So we can do things, if we support those devices, where we can actually find out what the ports are happening at the port and the interface level. What this means is that if I have a switch and I have 24 ports or something like that on it, I can determine which physical machines or which other switches are connected to each of the individual ports. This also helps in a virtualization environment where I may have 30 different virtual machines all going through the same physical NIC to a port on a switch, and I need to know how how those virtual machines are running. I can even map all those virtual machines to that port, so I know the interconnection between the switch layer and the virtual machine layer. We can monitor the devices inside the switch, like the CPU, the network, the RAM. So what that means is that we know if this switch getting overloaded or not. Once I've started this monitoring of these devices, we can give you some rich views of how these applications or these devices are performing. And we do that through our network summary view, where you can see a dashboard that shows you just what are my bad performers, which are the ones that you got to look at. We have a network vicinity view, and this vicinity view gives me a map of how these devices are interconnected between each other. And we can use that to troubleshoot where the problem might occur between two systems trying to connect with each other. And then lastly, we can give you some really detailed reporting on how are my systems performing over a specific period of time, or view the performance right now for those systems. So an example of what this looks like, if you look at the consolidated view of the networking performance, we can see that we have this dashboard that comes with Operations Manager that gives me just a quick summary of how things are performing and what's happening with them. And we'll drop into this in a few minutes in the demo. But you can see things like just a dashboard of what's going on really quickly, see which ones are green or red. We can identify which ones aren't performing appropriately, and then when something occurs, we can go deep into that device and see what's exactly happening. We can also give you a correlation between network devices and the hosts that are running there. That way, if I have a host that's down, maybe it's not the host that's down. The host could be running fine, but it could be the network switch that's down or the port that's down. And I can look into there and figure out where that problem might be occurring. And if there's something going on with the switch, I can pull up the details of that switch and see exactly what kind of switch it is and what devices are there. Now, these switch devices aren't just like Cisco. I mean, it's a multi-vendor support. So we have Cisco, Foundry, Juniper, a bunch of different devices that you can see how they're performing. So right now I'm going to switch over to my Operations Manager and show you what those things look like.
Great. So this interface you're pulling up, this is System Center Operations Manager 2012. Could you just give us a brief overview of how to navigate this?
Exactly. So this, what I've brought up here is System Center, like you said, Operations Manager 2012. And inside of Operations Manager, we have a bunch of different views. And the first workspace that we're going to look at is the monitoring workspace. Inside the monitoring workspace, we have the ability to see things like your discovered inventory. These are all the different hosts or Windows OSs that you're managing right here. And as you see, I have a lot of different hosts or machines, some of them virtual, some of them physical, some of them are running well, some of them have some issues, and I can drill down into them and see how things are performing. I also have those as distributed applications. Remember we had a service that we were looking at during the config and deploy sessions yesterday, this customer demographics application. Well, when I create that customer demographics application inside of Virtual Machine Manager, it, through the connector to Operations Manager, creates a distributed application inside of Operations Manager so I can monitor the health of that service through Operations Manager. And we'll talk a little bit more about that in the private cloud infrastructure session later today. I also can see things like my Unix and Linux servers if I have them, or Windows computers. But we're going to switch over to the networking in a few seconds.
Now, before we dive into the networking, I've actually seen a few questions about how Operations Manager 2007 management packs will work with Operations Manager and System Center 2012. Can you touch on that?
Yes, I can. So one of the things we really wanted to do, we know before when we've done upgrades to Operations Manager, is that taking all those management packs that you've already had installed and installing them in a new version can be challenging just in and of itself. But if you have to get brand new management packs and wait for them to be created, it can get really scary if you have a device that may take a while. We've worked really hard to make sure that the management packs we created in Operations Manager 2007 work in Operations Manager 2012. So you'll be able to take those management packs that you're using today and you'll be able to run them inside of Operations Manager 2012.
Now, using those same 2007 management packs, do you know if you could take advantage of new 2012 features such as the new dashboard views using those same management packs?
I'm not sure if you can combine those things together. You can create your monitoring views within Operations Manager 2012, so I don't see why you couldn't be able to do that, because you would create a view and you would create a new dashboard and just pull the information.
And you're pulling the data, right? The
Exactly.
data's still in the database.
It's the same data, exactly.
So we assume that that would be possible, yep.
The other thing is that we've simplified how Operations Manager works in 2012. So before we had this root management server and we had different groups, we've consolidated a lot of that, and there's some great blog posts on how we've consolidated those things together to really simplify both the way to deploy Operations Manager and to make sure that it has really good availability. Because of this simplification, we're actually able to up the number of devices that we're able to connect and manage through Operations Manager. So look into that if you're moving to Operations Manager 2012.
So while you're on the topic of the removal of the RMS role, you know, what is kind of the high availability story if our primary Operations Manager server crashes?
So
what happens?
From what I know on this is that you now have multiple Operations Manager servers that would basically handle the root. So if one goes down, the function would be handled by another one of those servers inside of there. So you still have to build for availability and have multiple servers out there.
Redundancy.
But there's redundancy in
Right.
there. Instead of having things have to bottleneck and funnel through one root management server, you can spread that load across multiples.
Well, that should lead to higher availability. I mean, that probably works great in branch office scenarios where you have multiple distributed servers as well.
It definitely does help and allows for removals of some of these bottlenecks that our customers were seeing with older versions.
Great.
All right, so in the network monitoring section, this is a brand new folder that you would see in the monitoring piece of it. The first thing I want to show you is the network summary dashboard. Now, this summary dashboard allows me to see all the different devices that are out there and how those devices are performing. If any one of these is having a problem, maybe its usage is running high, like the CPU utilization here is running higher than I expected, I can right-click on it, I can double-click on it and drill down into what's happening with those systems. The other thing is, within those systems, I can pull up what we call the network vicinity view. So I can pull up the network vicinity dashboard, and that gives me a map of how these systems are connected to each other. So from the device that I had connected, it'll show me all the different devices that are connected to that one device. And when this thing pulls up, I can see it over one or multiple hops. So this one device that I had selected when I brought up the vicinity dashboard was connected to 7 other different devices. Now what I can do is I can pull that out to say 2 or 3 hops and just see the network topology within my environment. For each of these different systems, I can drill down and get more detailed information on these systems and really see, you know, what maybe the BIOS version or the OS version for that device is and how they're connected in there. So let me see if I pull this one and I look at the properties. I can see that this device is it's a Cisco device. Its IP address is here. It's running it's connected via SNMP version 2. And I can see all the different information about that device and get some properties on that node. The other thing that I can do is, if this is a device, say, at my telco, where I route through it, but I don't necessarily have login access to that device. I can still get whether it's alive or not. So when I'm troubleshooting a problem, maybe I have a problem accessing the internet or something, and I know I'm going through a telco or something like that, I can still see, can I get to that next device? If I can get to there, then the problem is something upstream and not in my environment. So I have the ability to get rich monitoring for devices that I have control over, as well as at least details on whether the device is available or not, if I don't have login access to that system. The other thing is here where I can just click on Show Computers, and that would allow me to see the different servers that are connected to these devices. The other thing I can show you inside of network monitoring is the ability to monitor the performance or how these things are running. So some of the things that I can look at here are what's the utilization of these devices, what's the usage statistics within these devices, whether or not I'm having a problem with things like the memory of these systems. So I can pull up inside the performance view any of these systems and see how much of the memory is being used by these devices, or whatever I really want to report on. I have all these different informations for viewing the different ports, and I mean for viewing the performance of this system. And I can do it by device, or I could do it by just things within that system. Like if I look over here, I can see things like how is the ping response time for these systems and those types of things. So that is network monitoring within Operations Manager. It really gives me a view not only of my physical systems as well, but also of the network devices that they're connected to.
Is there any way of taking that network topology view that we saw and importing that to Visio, or importing that to some other type of diagramming system?
Yeah, so that network topology diagram there, I believe you can export it out into a Visio graph, and then, I mean, a Visio file, and then use that to create your own Visio diagram of your network. Or you can do things where you can create a Visio diagram and then import it into Operations Manager and put things on top of it so you can see how things are connected that way. If maybe you had a network diagram, a physical diagram of your switches that was in your data center with different rows or something like that, you could use that and map these things on top of it.
Great.
All right, so we can monitor for performance, meaning that we can see how things are performing now, how we can trend their usage over time. The other thing we want to do is we want to be alerted or know what's happening immediately if something goes wrong. So we give you through Operations Manager and the System Center components a really holistic view of the health of your systems. What we're really showing you here is that I have a system, and that system is running multiple different types of applications. Maybe it's running IIS, but it's also running an application on top of that. I have multiple management packs that view health on pieces of that application. What I can do within Operations Manager is I can pull all that stuff together and give you a consolidated view of the health of that system, and then you can drill down into that system if any one of these problems, if a problem's occurring on any one of these aspects of that server. So I have increased visibility here in that I can really drill down deeply into and know exactly what's going on. Once I do find that problem, I may already have existing knowledge of what's the problem, what are the general things that you may want to do to fix it, and all that information can be stored inside of this Health Explorer view. I can view health on a certain bunch of different things. I can do an end user experience where I'm injecting synthetic transactions into the application or through the website or whatever to determine, things like latency. Am I getting a bunch of latency on that application? I can monitor my .NET, my J2EE applications through application performance monitoring. If I have infrastructure-based type applications, SharePoint, web servers, database, Active Directory, those types of things, I can monitor those things directly, as well as monitoring my underlying physical infrastructure. So here I'm going to monitor my OS, my Windows OSs, my Linux OSs. I'm going to monitor the compute hardware. You know, if I have a management pack from, say, HP or Dell or IBM or something, I'll monitor that underlying physical system and see exactly what's going on with it, monitor temperature gauges, things like that. I can monitor my storage devices as well as, and we talked a little bit earlier about the networking devices that are there. So I really get this view, this all-up view of how these systems are performing. And I can do that whether it's Windows systems or Linux systems. We support many different Linux and Unix type systems. And here we're supporting things like Novell, SUSE Linux Enterprise Server, Red Hat Enterprise Linux, all these different Unix devices as well. And we do that through both management packs that we have, support that we already have inside of Operations Manager, as well as through partner-generated and created management packs. So we can look at things, not only Microsoft applications, Microsoft OSs, but OSs from non-Microsoft, as well as applications that are, you know, not Microsoft created. And all this is done through either our management packs or partner management packs. And inside of there, we can get OS-specific information. Like in this example here, we're looking at SUSE Enterprise Linux, and we're having a problem with the cron service. So it knows, you know, these are one of the things that you want to alert on, and this is one of the problems that we've seen inside of there. The other thing we can do, and we talked a little bit about this earlier, is that those applications that I create within VMM, I can import them into Operations Manager, and I can create my own distributed applications that can view the application layer and how the application views. So I can create an application called, let's say, finance transactions, or this customer demographics application, and I can see how the service is set up and performing via the integration within VMM. But also, maybe I have an application that has a web server, an application server, and a database server, and I can monitor the database server through the SQL management pack. I can monitor the application server through my custom-made or my partner-delivered management pack, and I can monitor the web services through the IIS management packs. But also, I can create synthetic transactions that are looking at this application, monitoring the performance, and I can bring all that stuff together into one distributed application. So if that application has a problem, it can bubble those problems all the way up to the top level application, and then I can drill down and find out where that problem occurs. And that allows me to help whether it's on Windows itself or on Windows Azure. So on a local on-premises private cloud or on Windows Azure. So we have a Windows Azure management pack that allows me to look into Windows Azure and the VMs, or the roles and the services that are running up there, and I can monitor how those things look as well. And I can do things like create a view that allows me to view both the on-premises side of the house and the Windows Azure side of the house, or if I have a solely Windows Azure application, and I can do all this stuff through Operations Manager.
Well, we have quite a few questions here, so I'm going to take a few minutes, ask a couple of these in a row here.
Okay.
So first of all, once we collect this data, are we able to export it to CSV type files or other formats?
So with the data that we have collected, we can run reports on it, and you can export those reports into some formats. So I don't know all the different formats that we have for that.
Great. And can we manage using PowerShell? Meaning, can we write scripts that call into Operations Manager and go and do different types of health checks?
You can. So Operations Manager has a lot of different PowerShell commands that you can use to run things against it, but also you can create tasks that if something happens, you can launch in to do something because an alert happens. So you can create tasks that run off of it too as well, and those can launch PowerShell as well.
Great. Now, how about applications that are Java-based? Can we monitor those?
So we can do some monitoring with Java that we have built inside of Operations Manager that I know of, but there also can be management packs that are created for particular applications.
You could always customize them, right?
Exactly.
And similar question, can we monitor the health of specific .NET web applications, such as performance, memory usage, transaction rates, either on a single server or across a whole farm?
We absolutely can, and if a better place to ask that question would be with Adam in the application performance monitoring section, because we've added a whole lot of .NET and J2E monitoring with application performance.
So I'm sure we're going to be going into more detail anyway with Adam on that
Exactly,
topic, right?
exactly.
Now, we talked about the networks, and you mentioned that we had some inbox networking partners. What if we have a network equipment vendor that is not included inbox? Can we still add support for them? Can they integrate with Operations Manager?
So there are a couple things. One, if they wanted to create their own management packs, they can absolutely do that, and you can bring those things in, or you can author your own management packs that are looking at specific counters and those types of things. We support SNMP version 1, 2, and 3, so if they support those versions of SNMP, then we should be able to at least connect in there and get specific information about how those network devices are running.
And final question in this nice batch here. What about monitoring storage devices, storage interfaces that go over networks, such as iSCSI, Fiber Channel over Ethernet?
So we can monitor your storage devices. What I've seen there is that there are custom management packs for each of the different stores, like NetApp has a management pack and other storage vendors have management packs that you would import into your Operations Manager system to do that storage management. The cross-vendor management that we do with the networking, we haven't fully integrated, we haven't fully put into a storage piece yet like that.
But using any type of third-party solution, writing custom management packs?
Absolutely. We can create these management packs that monitor storage and the things that I care about for those storage. Maybe if I just care about the network bandwidth between my devices and my storage devices, I would just monitor that. And that doesn't really have anything to do with storage. It's just your network. But if I want to monitor the storage device itself, that's where I would either use SNMP if it supports that, or a partner-provided management pack.
Great. So yes, you can.
Exactly.
All right.
All right. So the things that I want to talk about here is after I've created this and configured my environment to monitor these systems, I may want to do it in one or multiple different ways. I always have the Operations Manager console, and I can connect to that, and I can see everything that's happening inside the Operations Manager console. The other way is I can see these things through the Operations Manager web console. So a person that maybe needs access to see a certain thing or a certain task, but they don't need to install the full Operations Manager client, can just access the things that they need through the web console. And then lastly, I can publish this information through SharePoint. So I can create dashboards that people can use to see maybe how the things are performing quickly and easily without having to download and install the full Operations Manager thing. It's the same information, just different ways of displaying it for different organization uses, and then we grab that information either by talking directly to the management server, or we're going through the web server to get those pieces into the web view or the SharePoint parts. So we have the ability to create all these rich custom dashboards, and then we have the ability to surface them up any different way that we need to. So that was monitoring and keeping my performance and the applications running well. But now I want to start talking a little more about what can I do to keep my virtualization hosts up to date. So within that, we provide within Virtual Machine Manager the ability to baseline my systems and create these patch baselines. So I've done bare metal deployment with Virtual Machine Manager to my Hyper-V systems. Well, now I want to make sure that those Hyper-V systems have all the right patches. And every Patch Tuesday comes out, or every once in a while I'm going to need to update these systems. I want to be able to do that without affecting the virtual machines running on top of them. I would need to update the systems running on top of them, but I want to do it on their time, not when I'm taking down my physical systems. So first thing I can do is I can create baselines and find out what patches are, say, installed on these systems. Then I can assign these baselines to the particular hosts that are running in my environment and check these hosts against those baselines. If they match those baselines, everything's great. If they don't, and I check compliance and they're out of compliance, then I can push down the updates to those systems. One of the things we've done with this with Virtual Machine Manager is we've created the ability to update the cluster in an orchestrated manner. In other words, I may have a cluster that's running, and in that cluster, a new patch comes out. I don't want to take all those cluster hosts down at the same time, but instead what I like to do is take down a system, update it, but before I do that, I want to migrate all the different virtual machines off so I can move the systems off, take that system down, and bring it back up. So what it really looks like is this. Within VMM, what I'm going to do is I'm going to communicate with the WSUS server and find out all the different patches that are out there. I'm going to create now my baselines, and inside those baselines, I'm going to have, this is the level that I need these servers to be at. They need to have these specific patches available to them. Then after I have those patches and I know what that baseline is, I would scan all the different servers to find out which of them are in compliance or not. And if I have a set of servers or a cluster that's not in compliance, you know, they were in compliance last week, the patch came out, now I want to bring them up to that new level, then I would remediate the servers. And we would do that by taking one of these servers, basically putting it in maintenance mode, which would move all of the virtual machines running on that server off to other servers, patch it, bring it down and up if we have to reboot it, take it out of maintenance mode. So that way we've basically pulled it out of the cluster, updated it, put it back into the cluster. Once it's there and ready to go again, we'll then, that one's available, we'll put the next host in maintenance mode, dynamic optimization, we'll move all the different virtual machines off to the other systems on that host, we'll patch that one, we'll bring it down, bring it back up, then we'll do it with the next one. So we'll do it in an orchestrated manner so that we're applying these updates one at a time to each of these servers and not taking down all of my systems at the same time. Now maybe there are a few systems that I don't want to take down. So what I can do is for those I can create an exemption and bring them down later on. I don't have to do them at that same time.
Now, I was asked a question yesterday, you know, regarding a lot of these placement policies when we move a VM from one node to another. Will it always use live migration? Can it sometimes use a save state to quickly evacuate a host? What are the options that we have here?
So when we're moving things around by when you put a machine in maintenance mode, you have an option to either live migrate the VMs or save the state of those VMs. But if I save the state, it's not going to move the virtual machine. It's just going to save the state on that system. So we use live migration as the ability to move things around because we want to ensure that those machines are still up and running. So we're not going to we're not going to save state to stop any connection to them, move them to another machine and bring them back. It's safer and keeps the application up and running if we just live migrate them across. So we're going to use live migration for those.
I mean, I was also asked, you know, what is the usage scenario for when you might want to save state all of your VMs? Best example I could think of that is, let's say there's a virus, there's an attack, and you quickly need to patch the host as soon as possible. This might be a great example where you need to shut down the infrastructure, shut down the VMs, patch the host, reboot them, without having to wait for the time that it takes to do a lot of live migrations.
That would be one, or if it was, say, a development environment and I didn't care as much about the VMs having to be up all the time. But for the most part, I would think that because we're providing this private cloud infrastructure that's as always on as it can possibly be, live migration is the best way to do those types of things. Once you do things like save state, you're losing connection to those machines, so you really want to keep them up and running. Live migrate changes a little bit in the next version of Windows, as we've talked about at the build conference and stuff. So I still think, you know, when you do live migration, you're copying a lot of bits on the wire. We do it as fast as possible. So how we do it and how other vendors do it, it's going to take about the same amount of time to evacuate a host.
Now, I often get asked when we talk about update management, this patches the host, but correct me if I'm wrong, this won't go and patch the OS inside the guest because we don't know whether it's Linux, we don't know whether it's an older version of Windows Server, whether that patch is even applicable to what's running inside that guest.
Right, so what we're talking about here is simply update management of the host. We're not talking about the patches of the guests themselves. That you would do differently. So here we're updating the host because that underlying infrastructure component needs to be updated. I still have different ways of patching the guests. We'll talk about them in the next session. One way, if you're already using things like Configuration Manager, you would just have these as other systems inside of Configuration Manager and throw patches that way. Another way to do it is if they're a member of a service template, you can apply updates through the service template, which we'll go into extreme detail in the next session.
Now, what happens if you're going through this patching process and you apply a bad patch? Meaning we install a patch and this server doesn't reboot, it doesn't come online. Do we alert the admin and stop the process?
So we do. When we put this thing, when we do the updates, first of all, what we'll do is with the integration with Operations Manager, we will put the machine in maintenance mode in Operations Manager, so we're not going to get an alert for that update. But if the machine is supposed to be rebooted and it never comes back online, it won't continue to do the rest of them, and so you'll know that that update failed, and you'll be able to then troubleshoot that problem and then make sure that it doesn't work for the other ones or babysit the other ones as you do the updates there.
And I mean, that makes sense, right? You know, the reason why we do stop this process is we don't want to go and apply a bad patch to every host in the environment and take down the whole environment.
Right. We're not going to update the second host until the first host is back up and joined the cluster and ready to go.
So it's kind of like a sanity check. Let's make sure the patch works on one before we go and apply it subsequently to the other hosts.
You could do it that way, yeah. The other thing is there have been some questions about, you know, if I have an out-of-band type patch that maybe doesn't go through WSUS, can I leverage that? And with those patches, if I can use SCUP, I can get them into WSUS, then it would be able to something I could add to the baseline. But if not, then I would have to manually apply.
And SCUP, could you clarify what SCUP is? System Center Update Publisher. So SCUP is one of these System Center add-ons that basically allow you to go and tweak the metadata of a specific patch to make it more applicable. So you could then go and deploy it. You could say, you know, what type of OS it's applicable for, if there are any other requirements to use as part of installing that. So using SCUP, as you mentioned, it kind of gives you more advanced patch authoring capabilities. So you could say, hey, this patch really is applicable to this type of system.
All right, so we've talked now about monitoring the systems, making sure the performance is there, looking at the health of the system. How do I do automated updates or standardized updates for my underlying hypervisors? The next thing I want to talk about now is availability and recovery of my data center. I want to ensure that these infrastructure components are up and running, and if something goes wrong with one of these infrastructure components, how do I quickly fix it, and if possible, automate how I get through that? So what we're going to talk about here is some of the things that we have within Microsoft to help, within System Center, to help protect your physical infrastructure. And probably the biggest thing that a lot of organizations are using for that is Data Protection Manager, where they're looking at the applications that they have installed, they're looking at the servers that they have installed, and they're backing up those systems. And by backing up those systems, they can replicate them to other locations for backup and for recovery if there's a data center outage or something like that. So there are a few things I want to talk about here. The first one is with Data Protection Manager, we've optimized it for Microsoft applications, but really any application that uses a VSS writer can be backed up via Data Protection Manager, where we'll use volume status services to lock up, pause that machine and quiesce it and pause it. That data, we'll copy that data and we'll back that thing up. We've done a lot of work with Data Protection Manager to being more enterprise ready than in the past, and we back up now petabytes of data inside of Microsoft using Data Protection Manager. So there's a lot of work that we've done to make sure that we can back this thing up, whether it's to tape, it's to disk, or it's to cloud or another data center. We've also made it easier to manage your Data Protection Manager environment by importing including the Data Protection Manager console inside of Operations Manager console. So now I don't have to go to a separate console to do these other types of things. I can do it all from a centralized view within Operations Manager. We provide remote administration and role-based access. So now I can ask specific people that do just specific pieces to Data Protection Manager instead of having to have everybody have full access to those machines. So if you look at it, I mean, we really do backups, and we can do these backups in many different ways, where we can back up, say, every 15 minutes. We can keep a bunch of different backups, do a backup once, and then a bunch of incrementals on top of that. And the recovery is very straightforward and easy to do within Data Protection Manager. We have backup capabilities for things like Exchange, SQL, SharePoint, Dynamics, as well as your Hyper-V servers and the VMs that are running on top of them. So I can take a Hyper-V server that's running a bunch of different virtual machines, and I can back up that VM, that VHD file, using Data Protection Manager, and have a full, basically crash-consistent environment here that I can restore if I lose this this site over here or something like that. So we take that information from Data Protection Manager, and then when we get that data as we're backing the system up, we can either back it up to online snapshots, so I can do a disk-to-disk type backup, or I can back it up to tape and take these tapes and send them offline, or I can back them up to either another Data Protection Manager server that's either one that I own, or through our partners we have some data protection to the cloud, backup to the cloud. And what this means is that my servers get backed up, that data gets stored on my Data Protection Manager server, that data will be backed up to the backup server, so that if I lose my initial Data Protection Manager server, I lose the DPM server at the site, I can actually back up straight to that updated Data Protection Manager server, that backup one at the remote location. This means that I'm always continuously backing up these systems, and it means that for recovery, I can recover whether that data was stored locally or stored up in the cloud. The other thing is that we want to ensure that as the infrastructure is running, if I lose elements or the data center, I keep those applications up and running. So within the virtualization environment itself, I have the ability to, at a particular data center site, if I lose a physical server there, we'll bring up those virtual machines on another physical server within that cluster. So we have availability capabilities through the clustering capabilities of Hyper-V to, if one server goes down, bring those VMs up at another site. Once I bring that system back up, I can just live migrate those systems and rebalance the workload on the fly. So internal to my data center, these devices are available, and if something goes down, I can bring those systems up quickly on the remaining systems within the cluster. I also have the ability to replicate the data from my local site to a remote site, and I can do this via SAN replication. I can do this for recovery methods via things like Data Protection Manager, where I'm replicating the data to a remote site. And I can do something where I can create a multi-site cluster, where I can stretch that cluster across multiple data centers. And when I create that multi-site cluster, if I now lose the entire data center, then those virtual machines, because the data has been replicated from site A to site B, can be brought up quickly over at site B, or my second data center. What this gives me now is the ability to quickly bring these services back up in case of a failure. The other thing, though, is when I bring that site back up, or I've created a brand new site, I can then re-replicate the data from site B back over to site A and sync those data up. Then I can actually do a long distance live migration. So I can live migrate from site B over to site A, provided it's within the realms of synchronous replication between those sites, and move those systems over to the other site without having to bring them down when I want to fail back to my data center. Now, a couple things to note here. If I'm doing that, I need to make sure that the IP schema on both sides is the same. So I'm stretching my VLANs across, or I'm stretching my IP subnets across between the two sites. If I don't do that, and they have to have different IP elements on both sides, then what I'm going to have to do is shut the VM down, fail it over, bring it back up, and fix the networking part that way. But once I move them back over to the other side, then I can just resync the data the other way and keep this protection up and running and available to me. So this gives me the ability now to handle things like data center failures for my private cloud, but make sure that those systems are still up and running. The other thing I want to do, and the other thing our customers have told us is, there are certain tasks that I do every single time if an application goes down or something happens. I'm always going to first check to see if these services are running. Then I'm going to restart these specific services. Then I might have to reboot the machine. Or I have some process that I always go through every single time this problem happens. And I'm getting sick and tired of manually doing that every single time this problem occurs. Granted, some of these things, maybe fix what the problem is, but for some of these applications, you just can't fix it. This happens every once in a while. It always happens, and these are always the same things I do every day. So what if we could automate some of that recovery of those applications? What will that give me? Well, in this example here, I have this device, this SQL Server, and it's running, but an alert happens, and something's going wrong with the SQL Server. And I know that every time this happens, the best thing to do is to just take a copy of the database and move it to a separate physical server. Now that seems a pretty extreme example, but it's something that I could do if I needed to. So Operations Manager gets an alert that, hey, this SQL Server is going down. Maybe this is a one-time thing. I need to fix the SQL Server. Well, what will happen is as that Operations Manager gets that alert, Orchestrator could be looking inside of Operations Manager for these particular types of alerts. And if they happen, it could kick off an automated runbook that knows what to do to fix that problem. Or inside of Operations Manager, I could run a task that kicks off an Orchestrator workflow. So one of these things is that I know that every time I do this, I got to provision out a new VM, and I want to move that database SQL Server from the one SQL Server to the other. And so the first thing that Orchestrator is going to do is going to communicate with Virtual Machine Manager and say, hey, provision me out a new VM, get this thing up and running. Once it's up and running and available, and while it's doing that, let me create a new incident inside of my ticketing system. So it connects in with Service Manager and says, hey, this is the problem that's occurred. These are the steps that I'm already taking to do to fix that thing. An incident request is created, and it would go through the steps that it needs to go through, keeping that incident up and running, or that incident updated with where it's at inside the process. Then after I've updated that incident, I got the VM created, SQL Server is all ready to go, I'll take a full backup of that virtual machine, of that database server, and I'll restore that database server into the new SQL Server, and I can then bring down the existing SQL Server, and hopefully that fixed the problem that we had there, or hopefully I got that data off before that server went down. All the while, I'm updating the Service Manager ticket saying, hey, these are the things that I'm doing. This is where we're at inside the process. All this stuff is done for me automatically, so I don't have to worry about the fact that I may fat finger something or be called away right when I'm about to do one of these important tasks. I can automate those processes. So I'm going to show you now another view or another thing that might happen if we have a way to automate these processes and these tasks. So again, I have this application here, and it's this standard dinnernow.net type application that's running in my environment. This application here runs really fine, but every once in a while the service goes down. And I always go through a few steps every single time to test it out. First, I check to see whether it's up. If it's not up, I go and I restart the application. If that doesn't work, I restart the pools. So what I've done is I've actually created an Orchestrator runbook that basically follows the steps that I always do. So the first thing it's going to do is it's going to test the application. If it's available, great. It says, hey, whatever the problem was, it's been fixed now. You can continue on. The next thing I'll do is if it isn't up, I'll reset IIS. I'll basically go in and reset the web server and see if that works, because that works 90% of the time. And then I'll test the application again. If that doesn't work, the next thing I'll do is I'll restart the app pool. And if that doesn't work, then I say, those are the common tasks I always do. Let me pass this incident to someone who can do something about it. So I have a certain set of tasks that I do, and if the problem happens, and it'll keep updating the incident with what's going on with the system and run those tasks. So what you're seeing right here is the Orchestrator, System Center 2012 Orchestrator Runbook Designer. I can create different runbooks for doing all these automated tasks that I want to do. The first thing it's going to do is it's actually going to check in with Service Manager and see if there's an incident that's available, get that incident information, and then run through the test within this runbook here. So what that means is this. I have Operations Manager 2012, and I have these alerts that keep happening. And I have this application that's running, and right now everything's running okay. So for this application, I have some other alerts here, but not alert that I'm interested in this example. So let me just kick up the error so that we have the problem occur. So we saw that Dinner Now application is running, but if we look now, we refresh it, we see that we've killed the application. The service is unavailable. For some reason, this application went down. So I could be monitoring this application, and if we look at the monitors within Operations Manager, what we're going to see is that a new alert is going to come on that says, hey, this Dinner Now application is down, and more alerts will pop up as this thing gets alerted that, hey, there's a problem with this application. So we see the application's down. We look at the alerts here, they're coming up. Let's see if that other one came up yet. And at this point, if we look at this application, this one happened when this application went down, but other ones will come up that I'm looking at. I can, again, inside these management packs, put product and company knowledge if I have them. This is a custom design management pack. I also see inside of here that the default app pool went down. And if I look at that alert, this is an alert that came from the management pack for IIS. So we have a lot of product knowledge that says, you know, these are things that if this happens, these are the things that I would recommend checking on to make sure that that application is running and is okay. If we look now, we see that all those other alerts got popped up, and this is the alert that I'm really interested in, is saying, hey, this Dinner Now web application site is down. Now what's going to happen here is that these alerts are going to be imported into System Service Manager through the connector. So if I do a refresh here, what we'll see is that that incident that got created inside of Operations Manager will now be refreshed and brought into Service Manager. It takes a minute or so to have this thing pull into Operations Manager, so we'll just keep refreshing this a couple of times to see it pop in here. And at this point, it just how often and how quickly these two the connector runs, we'll see how fast these incidents get pulled into Operations Manager. It's going to take a minute or two to get in there. If we go back to Operations Manager, we can see that these applications have been down now for basically just about a minute. So as we pop back to Service Manager here and we hit refresh, we see that now these incidents have been created inside of Service Manager. If I pull up that incident that we're really concerned about and looking for, we can see the different information. One of the things to notice is that the source of this incident is Operations Manager. So it came straight from Operations Manager connector. We can see what priority, urgency, all those things that get created via the template that we have that says, okay, these are the types of things that I want to happen when this incident goes down. We can also see what is going on with this incident. Well, the incident was created. It's going to then kick off this orchestrator runbook called Web Application Auto Remediation. And this is a runbook that I've imported in through the connector with Orchestrator. And the runbook name it's going to run is called Dinner Now Fix. And if I cancel this, cancel this. What's going to happen now is that while this incident was popped up here, it goes moved over to Orchestrator, and Orchestrator itself will query the runbook, see if there's a problem. If there's a problem, it will then start running that application, and hopefully, if we waited long enough, it went through the task and automatically fixed that application. And as we see, because it takes a while to refresh, it did fix it. So from what I've heard from customers, they would much rather get that call in the middle of the morning that says the problem happened and we fixed it, instead of having to fix it like we said before. So this is one way where I can create those automated tasks that do all the work that I need without having to be there to manually run through those steps. And if something fails along the way, I can create inside of that runbook here the ability to have it alert the admin that, hey, this didn't work. I've tried all these different things. Now it's up to you to go in and fix it. So you don't have to spend your time doing the menial stuff. You can do the stuff you really care about.
So when you say alert the admin, what does that really mean, and how does that interact with Service Manager?
So alert the admin here, basically we go back into, if we look at the properties here, it's basically going to connect back into Service Manager, update the incident itself, that it did all of these different things. Then probably the next thing it would do is add a task that says, hey, this requires, in this example here, it says requires administrator assistant. We've did all these things, then you got to go work on it. The other thing it'll probably do is change the owner from, say, the automated task to a particular owner, which means that when that person logs in, it'll show up in his inbox inside of Service Manager. The other thing you could do is connect into, say, Operations Manager, create an alert that sends a page out to certain people, and they would get paged and say, hey, I got to fix this thing.
So again, it's kind of customizable as far as what alert admin does. It could send an email, it could send a page. You could trigger a script that goes and sets off someone's alarm.
10 different things if I wanted to. If I wanted to update the incident, but at the same time send a page, at the same time send a notification email, it could do all of those things at the same time for you. One of the nice things about Orchestrator here is that it has many different connections to all these different third-party systems as well. So I can, if I'm using, say, instead of Service Manager, I'm using Remedy as my ticketing system or something like that, I can always, update those types of things. The other thing is that worst case scenario, if I need to do something, I can run a PowerShell script, and that PowerShell script would allow me to go through everything and deploy those things out and send them to the right people. So I can I can get as fancy or not as I want to inside of Orchestrator. And the nice thing about it is it's a simple drag and drop type interface where I can drag in the specific tasks or things that I need to do into that to build that workflow and runbook and just fill in the information I need.
Great. So that's pretty flexible. There are actually a few more questions that have kind of come out around DPM.
Sure.
So DPM, can that support Linux and Unix environments?
So DPM could support them in a way where we could, if it was running, say, in a virtual machine, I could back up that VHD file, but I don't know how much DPM works inside of a Linux system. I think we need a VSS writer, so I don't think it supports it right now.
So you mean down to the granular level as far as backing up, restoring specific objects?
Files and those types of things, yeah.
Now, how about within a VM itself? So what's the level of granularity as far as can we back up specific folders in a VM? How deep inside a VM can we go and recover specific objects?
So you would do it one of two ways. For backing up the VHD file, you would use DPM against the Hyper-V server and back up the VHD file. If I wanted to do file level backup inside the VM, another way to do it would be to install the DPM agent inside that VM and just do the file level backup there.
So back up a specific folder, a specific database
right,
running
or if it was running a
VM.
SQL server inside of the VM, then I would install the DPM agent inside the VM to do the SQL backup from within the VM itself.
So I often get asked, what's better? Is it better to back up the entire VM, or is it better to back up the individual service that you care about running in the VM? And what are some of the trade-offs like storage capacity?
So there I think it really matters on what you need when you need to recover. If I just need the database, then backing up the database inside the VM is probably the best way to do it. If I need that entire system, Backing up the entire VHD is probably the best way, because what happens is there I have the entire state and everything inside the virtual machine, and I can quickly recover it by just taking that entire VHD file and building it together. As far as time and space and everything, backing up the VHD may have an initial large backup window because I got to back up the entire VHD file, but after that, the incrementals are going to be the same, whether it's
you're just backing up the delta, right?
Exactly.
You're not backing up the entire VM.
So I'm not backing up the entire VM every time. I'm just backing up the deltas between it.
Okay, and one other question around DPM. So as we talked about this disaster recovery scenario, if we have a multi-site cluster, we do need that replication that automatically happens from the storage on the first site to replicated to the second site. When we're using DPM replication, are there any conflicts, or can DPM replication be used as a way to do this cross-site replication?
So if I was using DPM to replicate between the two sites, then I wouldn't be using a multi-site cluster. The multi-site cluster requires that the storage device has that synchronous or asynchronous replication from SAN to SAN. But if I want to back up the site and then be able to recover at that remote site, I could use DPM as that way of getting the data from site A to site B using the backup of DPM to a DPM server at the remote site. When I recover there, I would then recover to local Hyper-V servers at that site instead of recovering over to a remote site. But it'd be a lot more manual process that I have to do for that.
Yeah, I think the big thing to think about when you're choosing what type of replication solution is your recovery time objective. So how much data can I lose? How quickly do I want to recover? Now, if you're using multi-site clustering and you're doing synchronous or asynchronous replication, you have a crash on the first site, you fail over to the second site, that data is pretty much already available.
Right.
That's the advantage. So you can recover quicker, you're less likely to use data. But it can be a more expensive solution. You need to partner with a third party.
And it could be a problem where if I get a virus over here, that virus got replicated over to the remote site. So I can't drop back 20 minutes or an hour because the data over there is the same data that was over here. So you have to weigh that in as well.
Absolutely. But at the same time, if you're using DPM with a full backup and restore, you will lose any data up to that last backup that you've taken.
Exactly.
And it's possible that restoring it could take longer than just a simple failover. If you actually have to go to a remote site, find that backup, take it off tape or take it off disk, restore it back. So there are trade-offs between the two, but both solutions are available as high availability.
And you probably want to use both. You want to use the multi-site clustering for quick failover, but the backup and recovery for being able to restore. So
you can certainly enhance. They are complementary technologies.
Exactly. They're not one or the other.
Now, I often also get asked, what about DFS replication? Why can't I use that? The reason why you can't use DFS replication, or why it's not supported in clustering, is it only replicates when a file is closed. So think about if you have a database, you have a VHD file, that's up and running all of the time. It never closes. That means that data is never replicated to a second site. So if you have a hard crash, you've lost all the data. That data has never been replicated.
Sure.
So for that reason, DFS replication is not a recommended, or actually not a supported solution in the scope of clustering.
Okay. All right, flipping back to the presentation, I'm just going to sum up here. I mean, we talked a lot about, we have this private cloud and we managed all these different infrastructure and created now this private cloud environment. We now are monitoring that underlying physical infrastructure to know how those things are performing and to be able to recover if something happens to them. So in the next session, we're going to talk about, how do I keep the private cloud available and up and running and monitoring that. But the things you want to take away from the infrastructure components, monitoring and operating that, is that we're proactively able to monitor that physical infrastructure so you know how it's running today, how it's been running in the past, and you can kind of trend what's going between what we were using before, what we're using now, and see how things are performing. I can view the health of my services and know now if there's a problem using the built-in knowledge or company tribal knowledge that I have, pull that stuff together to correct these infrastructure component issues. If I need to update these systems for running this private cloud, this virtualization, the hypervisor systems, I can do that in an approach that allows me to do it without bringing down the entire cluster. The VMs will be up and running. I'll just move them around to update those systems. And then I want to build a way of both ensuring that my applications are available. If they have a problem, be able to quickly get them back up, whether it's an infrastructure element that fails, my entire data center fails, or something in the application fails. Things I can do to automate those processes means that I'm going to get the recovery faster and get that RTO down a lot lower than it was before. So those are the main topics I wanted to discuss on monitor and operate the infrastructure components. I know from yesterday we had a few questions on the config and deploy of the infrastructure components. We want to talk about those. We can do that right now.
I think that's a great time. Actually, there's just a few other questions that have come up regarding other content that we've covered. So let's answer a few of those first, and then let's go back and cover some of yesterday's. So the first questions that came up were asking for a little more information about the SQL instance that comes as part of System Center 2012.
Okay.
So the full version. So first of all, do you know which version of SQL that is? 2008, 2012?
It's 2008 R2 right now, as far as I know, because it's whatever, I believe it's whatever is going to be available that's supported with System Center when System Center releases.
Okay, great. And do you know if it can be clustered for high availability?
I don't know what the use rights are for that.
Okay. My understanding is that it can be clustered, and there are restrictions around that, assuming that you have the hardware and you have Windows Server Enterprise Edition, Data Center Edition that supports clustering with SQL.
And at that point, you're only running the databases for System Center.
Again, still specifically for System Center.
Right.
And then, do you know how many databases that comes with? Is it a single database, or do you get the rights for the different databases for the different System Center components?
You get the rights for all the different databases for the System Center components. So if you want to install each System Center component with a SQL Server with its own database, you could do that, or you could have a SQL Server that's running multiple databases. A lot of people will probably combine things like the orchestrator database, the VMM database, and the app controller database, but they'll probably put the operations manager database on its own database server and service manager on its own. You have the flexibility to whatever fits your organization, provided if you're using the license that comes with System Center, you're only using it for System Center products.
Great. Now, moving on to some of the monitoring with Operations Manager. Speaking about the CMDB, when we go and discover new components that are available for us to monitor, can we directly look into the CMDB and say, hey, there's these new devices that have been added, I need to go and automatically monitor them? Or what's the automatic monitoring process?
So from my understanding within System Center, if we go back to the tool here, we have a connector between Service Manager and Operations Manager. So if I go to the administration tasks within Service Manager, we can see there are a few different Service Manager or connectors between Service Manager and Operations Manager. We have one connector that pulls all the configuration items inside of Operations Manager into Service Manager to store inside of their databases. We have the connection for the alert. So both of those are really pulling everything from Operations Manager into Service Manager. We don't have a push out from Service Manager into Operations Manager. So what I would recommend is add that server inside of Operations Manager, and then it'll get populated back into Service Manager, into the CMDB there.
Okay, great. Now, still around, networking components, can other types of networked nodes show up, meaning printers, scanners, other components that are connected to the network? Can Operations Manager go and monitor the health of those?
So in Operations Manager, under administration, we have a Discovery Wizard. And Discovery Wizard allows me to pick a type of device to discover. And I can pick Windows computers, Unix and Linux, or network devices. If I choose network devices, we use SNMP to connect to those devices. So what I would need to do is create, if those network devices support SNMP, then I can use them to do this. Or if I have a management pack from that particular vendor that supports that particular networking device, then I can do it that way as well. But I would specify the different SNMP information here, and this Operations Manager script would go out and discover it. So if that device supports SNMP, we can do it directly through Operations Manager. If it doesn't support SNMP, then you would have to get a special management pack or something like that, and I believe then you should be able to do it.
Great. Well, let's take a step back and review some of the questions that came up yesterday that we didn't have a chance to answer.
Sure.
The first one comes with Server Core and asking, Are there limitations as far as which System Center 2012 components we can install on server core? Now, considering there's no graphical user interface, you might have to connect remotely to it. Are there limitations that you know of?
Not that I know of, that we can't install these on Service Core, but from what I've seen is that most people install System Center on a full-blown version of Windows.
I mean, there's big advantages, right? You know, System Center has a nice graphical user interface. You really want to leverage that. So,
and for the most part, you can connect from a console that's installed on a different device. But for what we've seen, a lot of customers just install it straightly on a Windows system.
Great. And then we have a question about how do we do a bare metal deployment? Now, what I mean by bare metal deployment, I don't mean we want to go and just install, you know, the server roles to add VMs on it, to create a cluster. I mean, you literally got a new server straight from the hardware manufacturer. You plug it in, you give it power, you give it network connectivity. How can we go and actually do a full deployment, including installing that OS on it?
So that's the bare metal deployment capabilities we do with inside of VMM here. So in the fabric layer, when I do an add resources Hyper-V host, and I pick physical computer to be provisioned as a virtual machine host, it's expecting that you have a machine that has no OS installed on it or anything. When I go through this process, like I demoed yesterday, it will actually communicate with that baseboard management controller. So in an HP system, I have ILO. In a Dell system, I have DRAC. In the IBM system, I think it's called IMM, where if that system will connect to that out-of-band management system. So you have to have that plugged in. You have to know the IP address of that device. At that point, you give us that IP address of that device, of the out-of-band management controller. You pick the protocol you're going to use, whether it's IPMI or Smash or a custom provider, and we will communicate with that out-of-band management controller, tell it to Pixie boot, at which point it'll connect to your WDS server. The WDS server will authorize against VMM and say, hey, what OS do I need to install on that? And that's where we pick the different host profiles. So in the library, we have these host profiles that we can create for the different brands. Maybe I have multiple different HP brands or IBM or Dell brands or whatever OEMs out there, and inside of those systems I have specific things like what's the OS image I'm going to use, what's the driver set I'm going to install, those types of things. So if I look at the host profile and the properties of a host profile, I have a few things. First of all, it's based off of a particular VHD file. So I can have a VHD file that I've already pre-set up with most of the things that my hardware OS deploy would need, or I could have a VHD file that's plain generic and vanilla, and I can inject drivers afterwards. So the first thing I do is I put in the hardware configuration. So the management NIC, it gets that management NIC from the configuration stuff that I put in. So I said that this needs to be a static IP address. So it'll ask me. It was asking me in the wizard, what's that MAC address? That MAC address I put in is inside that physical machine. What's the MAC address of the management network I want to use? Not the out-of-band management, but the one that I want to turn on for Hyper-V network, the main networking adapter. Then the next thing it asked me is things like, what do I do? What kind of partition size do I create, and how do I partition the device? Do I use all remaining disk space? Do I just create a set size partition? And I want to make that a boot partition. And then lastly, it says, are there any devices that I want to add in there and filter drivers for the system? The other thing it asked me is the OS configuration. And this looks a lot like what you would see when you're creating a new VM. You know, what's the domain I'm using? What's the run as account I'm going to use to add myself to the domain? What's the local admin password I want to put in for this account? Identity information, you know, as I'm going through sysprep, it'll populate that information, product key, time zone. And then it has the answer file and the GUI run once. And this is where I can add in extra commands that specify, inject certain drivers or those types of things. And then lastly, if there's any specific host settings that I want to create, like where do I want to store these virtual machines after I've created them and installed them on that system. if I'm going to add these things to a cluster, I'd probably put, /cluster storage as the default directory or something like that. So this is where I fill in the information. Inside that VHD file here, that's where the OS is already installed. So it's an OS, it's a VHD file with an OS that when we install it, we sysprep it and install the new OS and everything on top of it. So that allows me to go from a bare metal machine all the way to a bare metal, no OS, no partitioning, anything installed on the machine, all the way up to a fully provisioned Hyper-V server.
Okay, great. I do have a few additional questions regarding this bare metal installation.
Sure.
Is there any way for us to handle firmware upgrades as part of this installation process?
So firmware upgrades there are ways to run some executable commands, but if it's something where I have to do it inside of the machine itself, in the BIOS before it even gets to that point, then I don't think we have that ability in here yet with VMM 2012.
Okay, and one final question before we wrap up this module. Now, we have some customers that might not have these fancy out-of-band management chips. Mm-hmm. Is there any way that they could still do this full end-to-end boot process by boot from VHD, by pointing to an ISO? Are there any kind of workarounds that they can
So
use?
within VMM itself, we wouldn't do that, but you can do all the things that VMM does through the baseboard or out-of-band management controller, but you would just have to do those things manually. Once this thing gets up to a point where it's just the OS, it doesn't even have to be configured for Hyper-V or anything like that, then you can add it into VMM, and all the additional things you would do afterwards, like attach a fiber channel or iSCSI to it, or set up the logical networking connections, those types of things. You can do a lot of those things afterwards as well. But to do bare metal install of the OS, it has to have an out-of-band management controller. So you'd have to do it that way.
Okay, and I have one additional question that's very relevant that I'm going to ask here as well. Okay. So we've really talked about this OS deployment being relevant for the host. What's our best recommendation for actually configuring the OS for VMs?
What do you mean by configuring the OS for VMs? I mean, you already have VM templates, and you would use those VM templates to deploy an OS inside the VM. Things that you'd want to do inside that VM, you'd want to turn off things like screensaver or, like high-end screensaver stuff that's wasting energy or wasting CPU cycles when it's not really active. You want to put the amount of processors that application is going to use. You don't want to give it 4 processors if the application is only going to run on 2, that type of thing. Assign it for the amount of memory that it's normally going to use, and then use dynamic memory to peak up if it needs to peak up, those types of things. But besides that, all your general VM practices that have been out there for years.
Okay, great. Well, thanks a lot, Ken, and that was very informative.
Sure thing.
I'm glad that we've touched on a lot of these open questions, so please continue to ask us questions. We'll definitely be answering them throughout the day. A lot of focus on answering your questions today. We're going to wrap up this module, take a quick break. When we return, we'll be back with Kenan, and we're going to focus on private cloud infrastructure, monitor and manage it. So really taking advantage of lots of these specific features for the private cloud, such as dynamic optimization, power optimization, service template updates, and some additional information about access and control. We'll see you very soon. Thank you.
Thank you.